Hi, guys. So I've had a couple of emails from students asking me questions about debugging, and typically at this phase in your coursework, I don't usually help students with debugging. So the first couple of classes, you're focused on programming, learning to program. In this class, you've been programming for a year. We assume that you know how to program, you know how to debug your code, and we're pretty much focusing on data structures. And how do the data structures work? So, if you come to me and you've got questions about how data structures work, or you don't understand what it's supposed to do, those kind of questions, I'm happy to work with you with. But you come with me, I've got a bug in my code, I've got some error, and I don't know what this means. Those kind of questions you should know how to solve yourself. You should have the skills to do yourself. The classes sort of build on each other, and it's like you're in calculus and you're coming to ask me how to add two numbers. Like, I'm not going to teach you how to add two numbers. You should know how to do that when you should have learned it before. That's a skill you should have had when you started this class. So that said, I'm not going to completely throw you to the wolves here, right? I'm going to help you out. I'm going to teach you something that I don't think that you know. I've talked to a couple of students, and it seems that you guys have not been taught how to use a debugger. So Eclipse, as much as I hate Eclipse, and I hate Eclipse, it has a debugger in it. It has a fairly reasonable debugger in it that works pretty well. You probably just don't know how to use it. So I'm going to teach you how to use it, and when I teach you how to use it, your world is just going to expand in how easy it is for you to find your bugs and your flaws. Okay. So we're going to start off. I've got a project here from a student and who shall remain nameless, and there's a bug in here. They think so on their computer this crashes. On my computer, it runs, but I noticed this odd lag. You see how the 11 takes like forever for it to finish, and on their computer it gives a memory out of memory error. Which is a really odd error. What it means is basically that your computer or the VM has run out of memory to allocate. So that's an odd error. And it may seem like it's very difficult for you to figure out what this is exactly, because it's not crashing anywhere, or in their case it actually is crashing. But on my computer it works. On their computer it doesn't work. Why is that? The first thing is, I think when you start debugging, is you really have to understand, what do the debug messages mean? What do the errors mean exactly? All right, you need to understand, not kind of like, oh, I've seen that before, or I think that means blah. You need to understand precisely. For example, when I said that this one means that the machine is out of memory, right? The VM is out of memory. That's a hint. That's a huge hint as to what the problem is with this piece of code. This piece of code is probably allocating memory in some incorrect way, right? Because I know this thing is a stack, and I know it's supposed to double in size all the time, and I also know that the initial size of it is 100. So when I look at this test.txt, I look at the stacks, and I don't see anything larger than 1, 2, 3, 4, 5, 6, 7, and actually you're going to be popping every time you see these. So I don't think this stack is going to go any farther than like 5 or 6, right? So why are you allocating memory? Why are you allocating memory? It should not be reallocating memory with this test set, right? So the fact that I knew what that bug meant means that I can diagnose what the problem is, or I have an idea of what the problem is. You should be the same way. You have a invalid pointer, invalid reference, or null reference, or a out of array error, or some other runtime error. You need to know what that means. And if you don't know what that means, you need to go and Google it so that you understand precisely what it means. Because the precise meaning is the key to figuring out what the debug is, or what the bug is. So you do not want to just kind of guess, wave your hands, because you're wasting your time. A lot of times, if you know what the problem is, you get an array index error. That means either you are going into the negative numbers, or you've gone past the end of the array. If you know that that's what the bug means, if you're very clear about what the bug means, then you know that probably you either have a calculation, either somewhere in your code you're calculating an index into an array and you're doing it wrong, or you're in a loop, and this is the most likely cause. You're in a loop somewhere, you're looping through the array elements, and you've gone off the end for some reason, or you've gone past into the negatives for some reason. So the knowledge of exactly what the bug means tells you exactly what kind of error you should be looking for. And if you don't know that, then you're basically reduced to just eyeballing the code and trying to notice if something looks like it's not right. And that is not going to get you anywhere, right? You're going to spend hours and hours and hours looking at your code, and you're never going to figure out why the problem is. So I am going to introduce you, though. Once you have some idea of what the bug is, I'm going to give you some tools here to help you figure out what the bug is more easily. So we're going to utilize the debugger, and I'm sure you've heard of this, but you're probably not sure what that means exactly. So the debugger it gives you the ability to step through the code incrementally, line by line, look at variables, look at expressions, peek into your data structures and see what they look like on the inside while your code is running. And that is as useful as it sounds, okay? All right, so we're going to start here. Usually when you start in your debugging sessions, what you're going to do is you're going to start by adding a breakpoint. You could have a piece of code that crashes. If you have a piece of code that crashes and you just want to look at what's going on when it crashes, to start your program in debug mode, what you need to do is push. See, here's the play that you normally push. There's a little bug right here. That is debug mode. If you push it in debug mode and your program crashes, it throws an exception or a fault or an error, it'll actually stop right at that point, and you can examine the variable values at the time of the crash. Okay? And sometimes that's useful and sometimes that's not useful. It just depends. Often it's pretty useful. You go in there and you look and go, hey, why is that array index -7? And you have a really good idea that that's where the bug is or what the bug is. But sometimes it's not going to help you, right? In fact, this error is one that is not going to... in fact, I can make it happen. I can make it happen on my computer, I think. Let me see if I can make it happen. Oh, let's clear this breakpoint. And continue. Oh, there we go. See, now I have the same error. Or I have an error here. Well, I have a different error here. Well, it doesn't matter. I still have an error here. All right, so I have an exception here. There is a problem with this number format exception input string. I go back here and I look at it and I see that the problem is that I have a plus and then a whole bunch of digits here. And I'm supposed to have a space in between. So you can already see that just by having the program break, so it's actually broken right now. The program hasn't exited. Normally when you just run it, the program's exited, right? But if you run it in debug mode, it doesn't exit. It actually stops wherever it was when it broke. And you can actually see this on here on the other side, you can see the call stack. So I can see where it was. Here I was in stack. It was in parse int. And it was in this parse int 52. We can look at it. It may not mean anything to what this is. But if we look at this, we can see S here. And we can see that, in fact, that token is not a valid token, right? So that's what the problem is with this bug. We can see this very clearly from using debugger. All we had to do was run it in debug mode, and so when it crashed, it doesn't stop executing. It doesn't exit. You see, it doesn't have any exit. There's no error printed out down here. It's just stopped here at the error point. So I can manually stop it with the stop button. I'm going to go back into my Project Explorer, and I'm going to go back and remove that because I don't really want to, I don't want that in there. It's not what I want to do. All right. So now let's go back and let's look at, let's say that doesn't really help us. That it's looking at the code where it crashed doesn't really help us. Or the program's not crashing, it's running like it is in my case, but it's not running correctly, right? That's another case. How do you fix this problem of it not running correctly? So what we're going to do is we're going to set what's called a breakpoint. So a breakpoint is, all you have to do to add one is you just double click here, right? And you see this little dot show up, and that is a breakpoint. And so when the program execution hits this point, it's going to stop. And I can add several of them anywhere I want to add them, and I can delete them by just clicking them again or double clicking them again. and they will appear and disappear in this column. There's also a really handy thing that you can do, which will clear all the breakpoints. It's in one of the menus here, but you can basically clear all the breakpoints. Here, remove all breakpoints right here, and that'll clear all the breakpoints that you've set in your code. So if you've been debugging, you got a whole bunch of breakpoints, and everything works now. Suddenly, you can just clear them all in one big thing. All right, but what a breakpoint's going to do is it's going to stop. So if I run it in debug mode, so I got to run it in debug mode, right? That's step one. You have to push debug, not the play. You have to push the bug. All right, I'm going to click debug. I'm going to save that. It's okay. So now my program has stopped right here at this line where this green thing is, right? I can look at my call stack over here. I can look at my variables over here. Here's my expression that I've read in. I can look at it. I can actually click on these things so that this pointer is the current object that I'm inside of. So I can actually look at it. I see it has a stack, array stack. I can actually look at the stack. The stack is all null right now, and there's 100 elements in it. This is all what I expected because I'm just running. All right, so now that I've stopped here and I've looked at all the variables, I'm gonna need, what I really want to be able to do is step through the program, right? So there are actually several ways to do this. There are 3 functions here for stepping through your program. There is step into, step over, and step return, and this thing was actually over here somewhere, and I dragged it here because I use it a lot and I like to do this. You can use F5, F6. You'll get used to just pushing the buttons eventually on your computer instead of clicking these buttons maybe. But step into is going to step, so if the current line contains a function call, step into is going to step into that function call, right? So this while loop has a parser.next, which is a function call. If I step into, it's going to step into that function call has next. Now that may be what I want to do, or that may not be what I want to do. In this case, this is some predefined function that I don't need, and I don't want to step through because I don't care. And so I'm going to use another one of the really handy ones, which is step return. So step return is going to step out of the function, the current function, up to the place where it was called in the calling function. So you see I'm here, I'm in scanner.next line. Here's the calling place in line 45 in evaluate. If I push this button, I'm going to come out, and I'm right back here in line 45, and I have completed this function now. And I am going to continue on into my code. So the last one that we're going to look at is the step over button. So the step over button will step over a function. You're going to use this one a lot because, for example, here, I don't really want to step into this parser. I don't really care what it does. It's a built-in function, so I'm not going to step into it and try to debug what's inside of it. It all works correctly, so I'm not going to bother with it. So I'm going to push step over. Step over will step over the function. And so that function is now executed, and I'm here, and you can look, you can see, here's my token, it's an 8. So my token is a number. I know it's a number because I'm looking at it. So now I'm going to step over this line because I know that this is operator is actually going to return false. I'm pretty sure of that, right? And which means the else clause ought to execute, and you'll see what happens when it clicks over. The else clause executes, and you look at this up here. It shows you the return value of the last function executed. So you can see it would return to false, which is what we expect because this is an 8, right? It's not an operator. So now we're looking at this function called stack.push, and this is a function that we suspect may have an issue. I strongly suspect that the problem is something to do with increasing the array size. When do we increase the array size? We do that when we call push, right? So I want to step into this push. I want to take a look at this push and see what it's doing inside. There's a bunch of parse int here and convert it to a new integer and all this trash. I don't really want to step through all of this stuff. I could step in, step out, step in, step out, but I don't want to do that. So what I'm going to do is I'm going to go over to the array stack code, right? And I'm going to find the push function, which is this one right here, and I'm just going to put another breakpoint right here. All right. So now I am here, and you can double click here if you want to see like what the call stack looks like, right? I can go through it. So now I'm here, and I want to go. I just want it to run until the next breakpoint, because I set a breakpoint in this function. So I'm just going to press continue, and what continue will do, it just resumes your program execution, and your program will run until it hits another breakpoint. So these are great for stepping over line by line, but if you want to jump over a big chunk or jump into some particular area that you're interested in, you can put another breakpoint in another file, and you just press resume. So now I am looking at this, and I'm inside of the push method, right? So I'm inside the push method, and I am looking at the first part of this. I want to look at this function, so I'm going to step through it. So I am going to step over it. So when I step over, I see that actually, for some reason, size was equal to the stack length, which is odd, right? So it's about to call expand capacity. This thing has a default size of 100. And this is the first thing I've pushed in it. So why am I calling expand capacity? That's a good question. If I look up here, I can see that size returned 100. So size is supposed to be the current number of elements that have been pushed into the stack, right? And then stack length is the length of the array. So what this is supposed to say is if the number of current elements that I've pushed into the stack is equal to the size of the array, then I need to increase the size because I got to push something else in there. That's what this is supposed to say, right? So we think that maybe the size function, it returned 100, it should have returned 0. So we go down to the size function, and we take a look, and we see that the size function is returning stack.length. So stack.length is the length of the array, which is 100. So now we see what the problem is, right? So what should this have been returning? So what this should have been returning is top. Now, I'll tell you that this thing, a lot of debuggers will go ahead and recompile when you make changes while it's running and then try to keep running. I strongly recommend that you don't do that. You can also do things like change the values and blah, blah, blah. If that's useful to you, you can. But we found our bug. We've used the debugger. We found our bug. We know what the problem is. So we're going to stop. Now we're going to run this thing again. Save the change. And now we notice it instantly executes, right? And in fact, to test this, to make sure that expand capacity is never getting called, I can put a breakpoint here. I can hit debug. Oops, let me clear this one. And then continue. I can clear this one. And I could actually have put it here right before the call to expand capacity. There's lots of places. I can continue. And in fact, we see that the thing executed all the way to the end, and that breakpoint was never hit. So sometimes this is another pretty useful thing to be able to do. You put breakpoints in places that you think aren't supposed to get executed. You're like, why is that function getting called? Let me put a breakpoint there. You put a breakpoint there, you can see the call stack. You can see who called it, why it was called. You can go up and down the call stack and look at all the variables and see what triggered it being called. Very useful thing to be able to do. I don't plan for it to stop there. It's kind of the negative of I want it to stop there. It's like, well, it should never stop there, so I'm going to put a breakpoint there, and if it does stop, then I'm going to know it. It's another very useful thing to do. There's lots of tricks for debugging. We'll go over those in later videos. In this case, I hope you just saw how to debug your code, how to use breakpoints, how to step into, step over, and step return, how to use the debug button to check and see what your errors are, how to look at variables in your code. Again, there's lots of things that we can do with this. We can add there's lots of features that we can do with lots of extra things we can do with the debugger. But those are the core things that are going to be most useful for you. So I hope this is useful for you, and I hope this helps you with your debugging. Thanks, everybody.